Once again, we welcome back to our lecture, still on regression and then correlation analysis. But this time, remember the other day or the first lesson that we had, our focus was regression of y on x. In that sense, we said that y was dependent on x, okay, and therefore the x was the independent variable and then the y was the dependent variable. Now the lesson we are going to have now is the regression, the line of regression of x on y. When we say of x and y, it means that the x is now going to depend on the y. X is going to depend on the y. Therefore, the x becomes the dependent variable, then the y becomes the independent variable. Okay? So, and the normal is that the first lectures that we had, our focus was on regression of y on x. We said that when we are having a y on x, then it means that the y is dependent on the x. Therefore, the x becomes the independent variable, the y becomes the dependent variable. But for the lecture we are going to have this afternoon, our focus is going to be on the regression or the line of regression of x on y, of x on y. So if it is x on y, then basically all what we are saying is that the x is dependent on the y, and the y becomes the independent variable. So going by the same equation, if y is dependent on x, then we have a plus bx. But if x is dependent on y, then we are going to have x is equal to a plus by. And so for regression, the regression line of x on y, this is going to be the equation that we are going to use. And so here, the x is the dependent variable, the a is the intercept of x, or what we call the x-intercept. The b here is the gradient. Then y becomes the independent variable. So that is it for what we are going to have. And so by that, we have to determine our values of x, our values of a and b, and then substitute them into the equation so that we can get the line of regression of x on y. Now, using the two normal equations discussed earlier, then I think our equation is going to be summation of x is equal to a n plus b times summation of y. And this is equation 1. Then we have summation of xy to be equal to a times summation of y plus b times summation of y squared. This one becomes equation 2. And so we are going to use these equations. And by that, like I did for the first instance, if we are going to look for, solve for the two equations, then in equation 1, summation of x is equal to a n plus b times summation of y. If you are to divide 2 by n, then you are going to get summation of x over n is equal to a plus b times summation of y over n. And this equation is going to give you an equation of the form summation of x over n is going to be x bar is equal to a plus b times summation of y over n, and that is y bar. And so if I want to solve for a, it means that in this sense I am going to get my a to be equal to the mean of y minus the b times summation y. Take note of this particular equation. Okay? And so if that is the case, it means that it's going to satisfy the points s y bar, comma, x bar. And so we can also do manipulation there to get our b. In that sense, our b is also going to be equal to n times summation of xy minus summation of x times summation of y all over n times summation of y squared minus summation of y all squared. Now what are we doing, or how did we get this? We did this by getting a from equation 2, getting b from equation 2. And so if you do solve for b from these two, equation 2, this is going to be the nature of the b. And so if you are going to divide through the numerator and the denominator of this equation by n squared, then eventually you are going to get the b to be equal to xy over this. Okay? And so we talk about this one to the covariance, and this one going to the variance of y. And so that is it. And we are going to use this formula, what we have, and the first one that we derived, to solve for the values of b and a, so that when we are done with that, we can get the equation or the line of regression of x on y. So I'm going to give you an example. You welcome back. So the example is that we have to find the percentage shrinkage in samples of clothes after washing in directions along and across the cloth is given by, I'm taking the question again, the percentage shrinkage of samples of clothes after washing in directions along and across the cloth is given by x and y. And so we are denoting the along. Okay, we are denoting the along by the x and then the across by the y. And so when we do that, we are going to have these values. So the across washing is going to be in this way, the along washing is going to be. So across we have 12, 4, 10. The percentage in it across is 12, and then 4, 10 in that order, and then along is 5, 2 in that order. Okay, so we have to use this one to calculate. We have to use this one to calculate the equation of the line of regression of x on y. Number 2, a row of cloth is sampled by cutting a narrow test strip across the row. The strip proves that the fruits prove to have a percentage shrinkage of 7. Use your regression equation to obtain an estimate of the percentage shrinkage to be expected along the curve. So they are saying that when you are done with getting the equation, then you have to test to see what percentage will happen. If there's a strip across which is equal to 7, what will be the nature of the along situation? And so in that sense, we're going to have the solution. And so in that sense, what we are going to do is that you're going to have what we call the xy. So the xy means I multiply this one by that. So we multiply 12 by this. This is 60. This is 8. This is 50. This is 80. This is 66. This is 80. This is 18. This is 24. this is 18, and this is 65. Now we have to find y squared. Try to find the squares of y's. So when you find the squares of y, 25, 4, 25, 64, 36, 64, 9, 16, 9, 25. And so when we are done, we find the summation of the x. So the summation of the x values. If we add everything here, we get 8, 8. And summation of y, if we add everything here, we are going to get 49. Summation of xy, if we add everything here, we are going to get 4, 6, 9. And then if we add everything here, that one too is going to give you 2 summation of y squared. That one too is going to give you 277. Okay. So when we are done with that, we can use the two equations that I gave you. But remember, we can substitute them into this equation, the two normal equations I gave you, which were these two equations. The two normal equations that I gave you. We can have summation of x to be equal to an plus b summation of y. That is equation 1. We have summation of xy is equal to a summation of y minus b summation of y squared. So we can substitute the values into that to get the two equations and solve them simultaneously. So summation of x is 88 into equation 1. Then we are having a, we don't know, okay, times n. N is the number of observations. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 a plus b, I don't know. So if I sum y, what is it? Summation of y is 49. So 49 b. So this gives me equation 3. This is equation 2. Then, what about this? The summation of xy is 4, 6, 9, and then that is going to give you summation of a times, so I don't know a, times summation of y. Summation of y is giving me 49 a plus b, I don't know. So b, I don't know, times summation of y squared. Summation of y squared is this value. So 277b. This is equation 4. So I'm going to solve equation 1, equation 3, equation 4 simultaneously. So let me make, say, let me make one of the variables the subject. Let me make a the subject in equation 3. And so I'm going to get a to be equal to, it's going to be 88 divided by 10, that is 8.8 minus 49 divided by 10, 4.9b. Okay, and that will be the a. And so I can substitute that one into that equation, and then go on to find a and the b. When you are done with that, you continue the process, and then that will give you the values of the a and the b. If I don't want to go through this process to get the a and the b simultaneously, I can use these two equations. After you have manipulated the two equations to get the b to equal to n times summation of xy minus summation of x summation of y divided by n times summation of y squared minus summation of y all squared. Okay, so what is the b? B is now equal to n is 10 into summation of xy, which is 469, minus summation of x, which is 88, times summation of y, which is 49, all over n is 10, times summation of y squared, which is 277 minus summation of y all squared, and that is 49 squared. And so if you simplify this one, you're going to get an answer. So you can take your calculator. I can take my calculator to do those additions. Okay, so let me go on. So when I do that, okay, so when I do that, I'm going to get a certain value for that. You can go through that. And so if I do that, I'm expecting an answer like that. So you take your calculator, you try to use your calculator to do the analysis there. So what is this? So I have 10 times that, and that is going to give me 4690 minus 88 times 49, and that is 4312 divided by 10 times that is 2770 minus 49 squared. So 49 times 49, which is 2401. So I'm going to subtract. So I have I'm going to have 4690 minus 4312, and that gives you 378 divided by 2770 minus 2401, and that's going to give you 36. Is it 3? No. What I mean is 2770 minus 2401, and that's going to give you 369. And so if I divide 378 by 369, I'm going to get 1.0243, which is approximately 1.02. Okay, so I can now substitute this answer that I've gotten into. Remember, we have said that the A is equal to, we said that A is equal to y bar, A is equal to y bar minus B times. Remember, we got an equation, and that equation was of the form. That equation was of the form. We said that the A is equal to x bar minus B times y bar. Okay, and so now that we have this, I'll just substitute the value of the B into the equation. And what is it giving me? I'll have my A to be equal to S bar. That is 8A divided by 10. Because we are talking about the mean, and 8 divided by 10 is what? 8.8. Minus B, I've got the value of B to be 1.0243 times, at this stage, we will be the answer for this map is a substitute to that. So y bar, what is 49 divided by 10? 4.9. Then you take your calculator, then you do that. So when I take my calculator to do that, I am going to have 8.8 minus, that is 1.0243 times 4.9. And what is this? 5.01907. If you subtract, what do you get? You are going to get 8.8 minus 5.019, which is like that. And the answer is going to be 3.781. So if you simplify it, you are going to get 3.8. And so finally, we are going to have the equation of x on y, which is giving us x is equal to a plus by equal to x is equal to our a, which is 3.8, plus our b, which is 1.02 times y. So this is going to be the equation, or the regression equation of x and y in this particular situation. But remember that the question is that we are to solve for a shrinkage around when x is equal to 7, and when there's a shrinkage across which is equal to 7. In that situation, we are going to substitute the 7 for the y, and then we are going to have x is equal to 3.8 plus 1.02 times 7. So if we simplify, the answer you get is going to be the answer. That is when the x is equal to 7. And that solves the answer. That solves the solve. That gives you the answer to it. So we are done for this lesson too. Thank you.